In this question, the ball has a mass of 0.1. It moves horizontally with speed 25 meters per second towards a smooth barrier xy, which makes an angle of inverse tan 7/24 with the horizontal. So if we come down like this and make that the x-axis, we can say tan A, if we put it in here, is, what have we got there, 7/24 opposite over adjacent, making the hypotenuse 25. So cos A is 24/25 and sine A is 7/25. So my speed is 25, so I have 25 cos A in the I direction, and it's going, we imagine it's coming down, hitting the barrier, it's coming down in a positive direction, positive negative, and rebounding up in this direction in a positive direction. It's probably the easiest way to look at this question. So 25 sine A minus 25 sine A in the j direction. Cos A is 24/25, so that's going to give 25 times 24/25 to leave 24i, minus the 25s will cancel, 7 in the j direction for before. Coefficient of restitution is 3/7, so no change in the I direction here. So we're going to have the new, which is x, over the old, which is minus 7, is minus e, minus 3/7. 7x is equal to 21, so x is equal to 3. So the new, or after impact, we're going to have 24i plus 3j. And we're looking for the speed, so the magnitude of 24i plus 3j is going to be the square root of 24 squared plus 3 squared. And there's a clue on the question here, it doesn't work out evenly, one decimal place, so type this into a calculator. You get 24.186, correct to one decimal place, 24.2 meters per second for the speed after impact. The magnitude of the impulse due to the impact. Okay, well, let's have an impulse here being m v minus mu. So the mass is 0.1. The velocity afterwards, 24i plus 3j. And then minus the 0.1 by before, which is 24i minus 7j. So we're going to have the 24s cancelling, so we just write 0.1 by 3 is 0.3 in the j direction, and then we're going to have plus 0.7 in the j direction, so just plus 1, if you want to put your 1 in the j direction, is the impulse, and the magnitude of the impulse is just going to be equal to 1 j in the j direction, 1 Newton seconds for impulse. Probably about the j, actually, I'll put it in the last question. And then the loss in kinetic energy to the nearest joule. Okay, so rounding off again, half mu squared for kinetic energy. Before 1/2, the mass is 0.1, 1/10, and the speed before was this 24 and 7, so we're going to get 25. We can see there, we were told it anyway, 25 squared, which is 625 divided by 20. I'll type that into a calculator now in a sec, and then afterwards 1/2 by 1/10 by this 24.2 squared, so it's going to be decimalized. So let's work out both of these as decimals. And the first one is 31.25, take away. Second one's giving me 29.28, and to the nearest joule it's going to be, we can knock off the hundredths, they're close to each other. 31 minus 29, which is 2 joules. In the final question in this section, a smooth metal sphere falls vertically and strikes a smooth plane inclined at an angle theta to the horizontal. If the coefficient of restitution is 2/3 and the sphere rebounds horizontally, calculate the fraction of kinetic energy lost during impact. Okay, let's make this our horizontal. So if we turn that around, you can see that u, if I do a diagram over here, it's going to look along these lines, that u is coming down in this direction and it's rebounding off at a right angle in that direction. So this is my U, this is my V. I have an angle theta. Theta would end up, if I continue that down, you can see theta would be in here and in here. Now putting it in the wrong place, I can see it's my alternate angles. It's going to be where V is. So theta is here. So this being a straight line, this is 90 minus theta. We don't know what that one is, and that one. So this is my diagram here. So U is going down in this direction, negative, negative. So my initial velocity is minus, minus, so minus U cos, and the angle is 90 minus theta that it forms with the horizontal, minus U sine 90 minus theta, which is the angle that it forms with the horizontal. And the cos of 90 minus theta is the same as the sine of theta. So minus U sine theta minus U, and the sine of 90 minus theta is the cos of theta. So this is my initial, this is before, after, do it up here, after, it's going to be V, so it's going away here in a negative positive direction with V, and the angle is theta in here with the horizontal, so we're going to have negative positive, so minus V cos theta. I've left out my I's and J's. In the I direction, and it's going to be plus V sine theta in the J direction. So we can simplify some of these equations. We have our before and after. I'll write them underneath each other. Minus V cos theta in the I direction plus V sine theta in the J direction. It's hard to see exactly where this is going. Now we can definitely equate these two I parts are not going to change. So U sine theta is equal to V cos theta. This might help us in a minute. And then before, so after, we don't know after, let's call it what we do. We know X, we know after is going to be on top and before for my coefficient of restitution. So V sine theta over minus U cos theta, to put the minus sign, is equal to minus E minus 2 over 3. 3V sine theta is equal to 2U cos theta. And if we divide this one by this one, similar to an earlier question, 2 divided by 1, we're going to get U sine theta here, and you can see the sine thetas will cancel, and V cos theta here, and the cos thetas will cancel. So we're going to get 3V squared is equal to 2U squared. So we can get V squared being 2U squared over 3, and we can get U squared being 3V squared over 2. This might help us with our kinetic energy. So let's look at kinetic energy, which we're looking for the fraction loss, the half mu squared. So that's a half times m, and we have u squared in terms of v here, 3v squared over 2. So that's going to be 3mv squared over 4. So that's my kinetic energy before. Afterwards, a half mu squared, well, it's going to be a half mv squared. It's going to become a half m times 2u squared over 3. 2's will cancel, so we're going to get mu squared over 3. So we need either both of them, m or u or v. So let's change this u squared into 3v squared over 2. So I'm going to get m times 3v squared, m over 3, times u squared. So 3v squared over 2. So that's going to give me mv squared over 2. So let's compare the two of these. We have 3/4 of mv squared, and then that changed into 1 over 2 mv squared. So we're at 0.75, we've gone to 0.5. We've lost 0.25 out of 0.75, which is a third. So a third of kinetic energy is lost. What were we asked? The fraction lost. So a third was lost. So that's the end of this question in this section.